In an effort to recreate what you might see on a standardized test like ACT or SAT, or what you might see in your classroom, the equation that I have on the board is scrambled. I wanted to have it in this format, so the very first thing that I want to do is switch the terms around so it matches this format. To do that, put your equal signs lined up and copy the equation the way that you need to see it. So this would be y is equal to. Obviously, our equation is quite scrambled. The 6 needs to be the constant, so we can just move that over into position. At least it's on the correct side. But these pieces have to flip over to the other side of the equation, so we are going to reverse them through the inverse operations. Okay, that one's lined up right. And now we'll do this one. What we have left is our original equation. The y is equal to 4x squared plus 2x plus 6. And now it matches perfectly the way that we need to see it. So we're good to go on this. At this point, I'd like to do a short analysis on what the 3 positions of the coefficients do to the actual graph. Remember, this is a parabola. The very first position, if we have, and this is noteworthy, you might want to put this in your notes, so you can refer to this when you need to. The first position, if we have a positive coefficient, we're talking about this 4, this 2, and this 6 at this point. If we have a positive coefficient of the a term, our parabola opens upward. Negative opens downward. If in fact we have an increasing number here, if the numeral increases, then the width of the parabola increases. So now a positive 4 might be this way. If this were a 14, we'd have quite a wide parabola. And if this were just 2, you might have a parabola that looks more like that. All of them would still be upward facing, but the width of the parabola would be different. The second term, the b term. If b is changed and nothing else is, so we're going to leave it, this as 4 and that's 6, but we're going to change the number, the numeral on the b, we're going to get a side-to-side movement. So your axis of symmetry might be here, but as this number changes, the axis of symmetry could shift to perhaps this. So you might have a 1, 2, 3, a negative 3, x is equal to a negative 3. In this case, you might have x is equal to 2. So your parabola shifts right or left. From side to side. These are all questions that you could answer from just looking at your formulas or comparing the formulas itself, the actual equation, not necessarily having to go through all of the work of finding the exact axis of symmetry. You would be able to just eyeball it, and that saves you a lot of time. If the constant, the c term, in your equation is changed, that tends to move the parabola up or down on the coordinate grid. So we have, in the first position, if it's a positive coefficient, the parabola is upward facing. If it is a large number, the parabola is wide. The second term, none of the other numbers are changing, just the b term. Then that moves the parabola left or right on the grid, and the constant moves it up or down on the grid. That's very helpful to know. You'll be able to analyze those questions quite quickly.